Welcome to the online lectures for software engineering. In today's class, we'll be discussing the topic testing strategies. The topics that we'll be covering today are these, beginning with a strategic approach to testing. Now, there are different characteristics of strategic testing. Now, what is testing actually? Testing is basically a set of activities that you're going to plan in advance so that you're going to conduct them in a systematic fashion. So, system is a set of activities that you're going to plan and then you're going to conduct them in a systematic way. Now, to perform effective testing, you need to, like a software team should conduct different technical reviews. Now, the main aim of conducting technical reviews is that you get to know what type of testing needs to be done. As you're going to make a plan, you can make an effective plan of testing if you conduct different technical reviews with the different teammates that are developing the software. Now, testing is going to begin at the component level. That means you're not going to conduct, if this is the software that you're developing that has got some 6, 7 components in them. So you're going to come test one component at a time. You're going to test one at a time. Then you're going to leave that test component 2, then test component 3. This is going to go on till 7. So you're going to test each and every component individually, and then you're going to test the entire system. Now, testing is conducted by the developer of the software and by an independent test group. That there are two people that are going to conduct the test. The developer, that is the one that has designed your software, and another independent test group. Now, here we'll be studying two different types of testing. You're going to study alpha testing and beta testing. Two types of the testing that are done. One is done by the developer and one is done by the customer. Then test now there are different types of testing, and here different testing techniques are used at different points of time. It is not the case that if one test case is there, that will be applied to all the functions. You're going to use different techniques for different instances. Now, this testing and debugging are different activities. Two different activity. Testing is you're going to see whether the particular software is giving the correct output that was desired. And debugging is basically removing the different errors. The next is verification and validation. The most important short answer question, difference between verification and validation. Now, what is verification? Verification is going to mean are all algorithms coded correctly. That is verification. Whereas validation is, does whatever software you're making, does it meet the user requirement? That is what you have developed. That is the same that the customer has requested in the first place. So coming to the definition, verification, a set of activities that ensure the software is the software correctly implements a specific functional algorithm. Whereas validation is a set of activities that ensure that software has been built is traceable to customer requirement. That is what was stated by the end user. That is what you're developing. It should not be a completely different thing. The next is a strategy for testing conventional software. Now, there is a diagram that represents the conventional software strategies. You're going to begin abstract to concrete and then narrow to a broader scope. The different testings are, you got system testing, validation testing, integration testing, unit testing, code testing. So you're going, this is your all types of testing. This is your core when you when you the first phase begins at the system engineering, then getting all the requirements, then making the code. Now, when you've designed the entire code, you go to the testing part of the fifth. So four types of testing. Now this testing is going to begin unit testing. Unit testing is testing each and every component individually. As I've told, you're not going to test the entire system as a whole, you're going to test each and every component separately. Then integration testing is that when you've tested all the components separately, you're going to check whether this components, when they are deployed, whether they were working properly or not. That is your integration testing. Then comes your validation testing. Now, this validation, the previous slide that we discussed, verification, validation. Validation is going to ensure that project is going to meet the customer need. Then you've got system testing. System testing means testing the entire system as a whole. So this is how you're going from a narrow to a broader scope, beginning from a small things and then completely testing the entire software. So these are different strategies for the conventional softwares. So there's in detail about each and every testing. Now, unit testing concentrates on each component function of the software as implemented within the source code. So now this is going to ensure the entire complete coverage of entire error detection. Error detection is and maximum error detection you're going to find out. And then when you've done unit testing, you're going to go with the different components are going to be assembled. Then the next is integration testing. Now, integration testing is as I told different components you've tested, you're going to assemble all of these components. So this integration testing, it is going to focus upon the different inputs and outputs and how these different components fit together. When you're integrating different components, when you integrate first, second, third, three components in a system, how they are, whether they're working properly or not, whether they're giving you the desired output or not, or if any other errors are introduced, that you're going to find out. Then within validation testing, you're going to check whether the system meets the end user's requirements. So here you're going to focus upon all the functions, you're going to focus upon the behavior of the system, the performance of the system, each of the things is focused here. Then in system testing is testing the entire system as an entire whole. All functions and performances achieved or not, here you're going to identify. So these are the steps for conventional software. Then the next is the drivers and stubs are used in unit testing. So what is drivers and stubs? A driver is like a main program that accepts test case data and passes the data to the component being tested and prints the return result. So here driver is a program. It is going to take all the data as input. So here your data is going to be your input and this data is going to be passed to the component that is being tested. So this is the component that is under test. And then when you're giving some input data, you're also going to record what is the output of that particular component. So this is the job of the driver. The next is stub. This serves to replace modules that are subordinate to or called by the component to be tested. So here you're taking the component that is being tested. Here you're going to focus. Here stub is the one that is component that is being called that is you're going to test. It's the same thing. There was a component that you're testing. It is going to use the module's exact interface, may do minimal data manipulation, provide verification of entry, and returns the control to the module undergoing testing. So within the stub, what you're going to do is that you're going to take the entire exact interface. And you might make any changes with the data that is the input that you're taking. Here, some changes can be done. If those changes are there, these changes are done based upon the user's requirement and then you're going to record the output. Now this you're using this drivers and stuff both must be written, but they do not constitute any part of any installed software product. This is used only for unit testing. Now this is an example of a test scenario. This is an example for your test scenario. Now the test scenario is login. You're going to check whether the login page that you have designed, whether it is working properly or not. The test cases: login negative test case, test priority is high, any prerequisite or post requisites are there, that will be written. Now here, first launch the application. Here we are testing the Facebook application. Now when you want to test the application, first you're going to launch it, that you're going to open the application. The expected output should be Facebook homepage should appear. Then you're going to run the application and you're going to check whether you're getting the same output or not. Then the browser that you're using, that is written. Then if suppose the expected result is same as your actual output, then the test result will be passed. Then test comments will be who is the person that have tested the particular component. Then as this is for checking the login details, you're going to enter invalid email and password and hit the login button. You're giving a wrong input here. Now, if you're giving the wrong input, the email, phone number that you've entered doesn't match any account, and it is going to ask you whether you want to sign up for another account. So, actual output is the similar to your expected output. So again, the result is going to be passed. Now, when you're testing, you're going to give a wrong password, you're going to give a wrong input, and you're going to give a correct input and check. You're going to give two cases because you want to check what happens when you give some wrong input. What happens when you're going to give correct input, whether the system is going to work efficiently or it is giving the same result or not, that is identified. When you give the correct input, the password that you've entered, here you're giving us enter valid email ID and incorrect password. So here you've entered the wrong email ID. Here you have entered the correct email ID but wrong password. Here you've entered the correct password. So here you're checking all types of scenarios. Then the next case will be the third case will be you'll be entering a correct ID and correct password, and you're going to check what is going to happen. So when your actual expected output and expected output and actual output are same, then the result will be pass. So this is what is called as your test scenarios. Now these test scenarios are planned in advance. And the next is validation testing. Now in validation testing, there are two types of testing as I told. There's alpha testing and there is beta testing. So first, you've got alpha testing and you've got beta testing. And the first point in alpha and beta testing is that alpha testing, this is basically done at the developer's side. That is, the developer is going to test the system. Whereas in beta testing, testing, this is conducted at the end user side. That is, in the real-time environment, you're going to do this testing. Then the second one is this software is used at a natural setting. That is, you're not going to make any changes here. You're just going to test the software, and as the developer is testing it, here the developer will be watching what you're doing. The software is tested at a natural setting, and here the developer is present and he is watching. Whereas in beta testing, the developer is not present. Then the next one is, now as the developer is doing the testing, you do not have any real-time environment. So this testing is done at a controlled environment. Any changes are there, you've got team that is going to help you do that. Whereas at the beta testing, as you're testing the application at the end user side, this is going to serve as a live application. Now when the system is is serving as a live application, the software, the environment that this software is being run, this cannot be controlled. The environment can't be controlled because you do not know what error might occur, what type of data you're using. So this is the differences between alpha and beta testing. Now at the end of beta testing, the different errors that are present at the end user side, all those errors or problems, these problems will be recorded or they will be noted and they will be passed to the developer for making any changes or for providing service. So there's a difference between alpha and beta testing. In an important short answer. The next is system testing. Now, within system testing, there are again different types of testing. You've got recovery testing, securities testing, stress testing, and performance testing. Now, recovery testing is you're going to test for recovery from system faults. What you're going to do is when you've designed a system, what you're going to do, you might intentionally pull the plug of the system and you're going to see how the files are going to be saved, whether they're going to be auto saved or all the files, all the data that you were working on, whether they are going to be lost. So this you're going to intentionally make faults within the system and you're going to check how the system recovers from a system failure. You're going to force the software to make error. You're going to intentionally give some wrong input and you're going to check. The next is security testing. Within security testing, you're going to verify all the protection mechanism that you put in place, whether the system is safe or not. You're going to check within the security testing all the different security patches that you have used. You're going to check whether they are up and working. Then the next is stress testing. As the name suggests, stress testing is you're going to load your system with a lot of input and you're going to see how the system is going to work under a lot of load or under stress. Then the next is performance testing. Within performance testing, you're going to check the performance of the system. You're going to test the runtime performance. It's in how much time you're going to get the results. You're going to check the performance. Now, this performance testing, this is normally seen with a combination of stress testing. That is, if suppose the load of the system is being increased, whether the performance is increasing or decreasing. So, performance testing is all affected by your stress test. That is, you're going to have different values under when the system is under load and when the load is being reduced. The next is the art of debugging. Now, this debugging process, this is basically going to begin after the execution of a test case. After the execution of a test case, the debugging becomes. Now, why this has become after the execution of test case? This is because when you execute a test case, you are going to get to know if there is any error or not. When you get to know there's an error or not, you're going to begin with the debugging process. Now, debugging is a consequence of a successful testing. That is, when you've successfully done the testing, then go to the debugging process. Now, the job of this debugging process is that the different symptoms of the system, the different errors, they are going to try and match it to the error, or they're going to try and match it with the cause. What is causing the particular error? And then you're going to go for error correction. Then why debugging is difficult? Now, this debugging is difficult because sometimes the symptoms and the cause may be geographically remote. You might not have the symptom and causes, they might be at different locations. The symptoms may disappear when another error is corrected. Sometimes what happens when you execute a particular program, the system might have some two errors might be there. Now when you fix one error, the another error is also gone. So this might be a case. The symptoms may actually be caused by non-error. That is, it is not actually error, but it is due to some rounding of accuracy. Suppose you're giving an integer value, but you've used a floating point value. So you're just rounding off the numbers. That is also going to introduce the errors. The symptoms may be caused by human error. Human error means you might just do some very small, simple, silly mistake. Now, when you're debugging, you're going to focus upon the logic of the code, but the normal error is it might be a spelling mistake or something that, so these errors become difficult to find. Then it can also be symptoms that can be caused due to some timing problem, that is a program uh, is not being executed at a particular time, it is not able to fetch some files. That can be a timing problem. Now the another cause can be, sometimes what happens is a number of programs are running on a single processor, so that can again introduce error. Now, the three questions that need to be asked before correcting any error: is the cause of the bug reproduced in another part of the program? That is, whether a similar error can be occurring in another part of the program, that will be identified. Whether a similar error can be there in another part of your program. Then what next bug might be introduced by the fix that I am about to make. This means that the source code that you've done, that you've coded, it should be studied so that you're going to identify the logic, the different data structures that are related. So when you get to study the different logic of your program, you're going to see making any changes within the program, whether it is going to affect the other part of the program. So you're going to study the logic and the data structures of the program. Then the next is, what should we have done to prevent the bug in the first place? Now, this is the first step towards your software quality. That is how you're going to avoid the different errors that are going to. Now, by correcting the process, you're correcting the product also. When a bug is being removed from a program, it is also eliminated from other future programs when you focus upon this third point. So these are the three questions that are asked for correcting the errors. So this following this makes your debugging process easy and a way lot simple. That's the end of today's class.